morning, everybody. It is a great pleasure to be able to deliver this presentation today, and I'd like to thank the organisers for inviting me here to this wonderful venue. We find ourselves in interesting times, and perhaps the title of this brief presentation should have been Automation Adoption within the shipping industry. So, what does navigational safety mean to you as a person, a business, or us collectively as an industry? And what role could technology like augmented reality play within this? A variety of measures have been put in place to increase the safety of ships at sea. Some of these span different parts of the industry, such as pilotage or vessel traffic services, whilst others are more procedural in nature, such as ship routing schemes, and others involve the use of technology such as ECTIS, AIS, and the advancement of hydrographic information and data. These are all independent pieces of the same puzzle, with one goal in mind: to improve maritime safety. Augmented reality bridge systems have the potential to connect the gap between all of those distinct components, displaying information in an easy to absorb format. Now, in order to avoid the erosion of seafaring skills and experience, it needs to be done properly. Unlike the fully autonomous vessels we've heard about so far, this technology can be utilised in conjunction with officers to supplement navigational operations at all stages of a voyage. So instead of replacing seafarers, computer processing and automation can be used and combined with human expertise and potentially increase productivity and assist with safe and efficient navigation and cargo operations. Before delving into the benefits and drawbacks of such technology, we must first understand what it is and how it could be used. Augmented reality complements or enhances your surroundings by delivering data about your environment, allowing you to make judgments using both your senses whilst utilising technology to better inform. It is frequently mistaken with virtual reality, which entails depriving one or more of your senses. Augmented reality is the most recent advancement in a long line of technological development that began with military aircraft. For decades, fighter jet pilots have employed head-up displays and other advanced flight systems to gain a tactical advantage in the airspace over a battlefield. Head-up displays are static units that give important information to a pilot, and since their inception in military jets, the technology has evolved and spread to commercial and private jet flight decks. It has significantly improved the flight deck experience and has contributed favourably to the prevention of accidents in the aviation industry. There are various advantages, including providing the pilot with the information they require to fly the aircraft without having to look down at their instruments, boosting situational awareness and lowering the workload on the flight deck. Augmented reality goes one step further than a static head-up display. It does this by allowing the pilots to scan out of the window and still see the important information as their heads move and scan through the horizon. This technology has successfully transitioned from the military to commercial airliners and has made an impact. Now, although there are obvious differences between aircraft and ships, and how they're operated. But the idea on which the concept is built to display information may be transferred, and in actual fact has been transferred to our industry by individual shipping companies, with the immediate result of improving safety and situational awareness on board. Now, your workload can influence your understanding of your surroundings and impact your decision-making process. There can be a lot going on during periods of intense navigation, with multiple different tasks to deal with while on watch. It has and continues to cause people to miss things. Augmented reality provides a level of help that was previously unavailable. This type of technology has applications for improving situational awareness and reducing workloads during critical navigation periods, such as approaching or departing ports, operating in low visibility or busy shipping lanes, by assisting the mariner on analysing vessel movements and only including other vessels that pose a risk to your own vessel. Individual views, attitudes and pressures may also prohibit crew members from addressing issues before they become more serious concerns. It is often the case that small issues grow into larger problems unless they are discussed and resolved, and therefore ensuring the incident doesn't happen. In these cases, augmented reality systems can enhance awareness of possible problems before they worsen. The system cannot be preoccupied or disturbed by members of the bridge team and uses multiple sensors and algorithms to provide timely guidance to bridge teams, alerting them to any difficulties compromising the vessel's safety. The concept has an unrivaled ability to take information from a variety of sources, process it, prioritize it, and simplify it, so that the officer of the watch can focus on what is important. In a congested shipping lane, for example, an augmented reality system can identify, observe, and prioritize vessels that may be of a concern to the officer of the watch, increasing the situational awareness, decreasing workload, and allowing the officer of the watch to focus on what is of urgent concern to the vessel's safety. Advancements in data technology may be swiftly disseminated to sailors, and historical information, such as a port accepting deep drafted vessels, can be analysed in the voyage planning stages to develop an awareness of any special concerns with a port. For example, you will be able to observe how vessels of a given draft arrive and exit a port, as well as if anything must be discussed or raised with the pilot, which can then be overlaid on the augmented reality display. Before moving on to the hurdles of such technology, I'm curious if this concept would lessen the amount of unsafe port claims that clubs see, or at the very least allow owners to vigorously defend themselves against any such accusation, as digital evidence is growing in popularity to resolve such issues. Automation and augmented reality are far from flawless and still very much in their infancy. The system will always work within the constraints of the programming that surrounds it, and while artificial intelligence is capable of learning and adapting to its surroundings, the computer must initially understand what's going on around it and how to respond to that information. There is also an argument that the crews could spend more time interrogating menus and trying to find something within the system during periods of critical navigation, so that rather than improving situational awareness, it may detract from it when officers are interacting with the system because they want something specific displayed on their glasses. If implemented, there will be a raft of training issues which will manifest themselves over time. This includes transitional training, initial operating risk, and concerns around skill loss and retention, which this last point flows back to training departments being able to identify solutions to these problems. The introduction and subsequent adoption of any revolutionary technology, however, raises the danger that crews will come to rely on it, often to the expense of abilities such as ship handling experience. One of the most evident issues I noticed during my time as a master and pilot was the habits of officers having their heads buried in the ECTIS or radar units, failing to look up and out of the window. With a visual approach, you can quickly learn how a vessel reacts to internal or external factors such as rudder or wind movements. Visual navigation is vital, and with such technologies on the bridge, critical information may be conveyed without the bridge team's eyes ever leaving the windows. There will always, however, be flaws with source code in any software, and this is not always clear to the programmer during development, and difficulties frequently emerge when software is utilised in the real world. This brings us back to the previous concern about over-reliance, because being too reliant on software may give the watchkeeper a false sense of security, which could lead to catastrophe. The clubs deal with various collisions and groundings that could have been avoided, and once they are investigated, we frequently see a similar chain of events leading to whatever has happened. Augmented reality could be used to reduce the number of and severity of incidents, but it must be balanced, as it may not always result in the desired impact, a reduction in incidents and casualties, but rather an increase due to the causes resulting from the use or reliance on technology. It is critical to not lose sight of fundamental values in a digital age, yet technological advancement cannot be ignored and has shown a gap in the way we teach sailors. We pre-program them in the classroom to think, act and reason in a certain way, and when they join ships they must immediately think and act differently. Altering a mindset entrenched during training. It is critical to address these concerns and training mariners of the future in advancements and types of technology, whilst preserving skills which have been tried and tested over the years. Finally, manual abilities such as ship handling are essential for obvious reasons. Being able to use your senses at sea is also essential. I would suggest that the type of augmented reality technology we have explored briefly here today would enhance rather than replace our senses. Indeed, augmented reality tools could be utilised as excellent on-the-job training tools for junior officers, exposing and instructing them on what the master is utilising to manoeuvre the ship safely and efficiently. This on-the-job training is often different depending on who teaches it, but is often a vast database of information that goes untapped. Augmented reality could change this by taking this knowledge, learning from it, and guiding officers and allowing for the planning of more realistic simulator exercises during training. It will be intriguing to watch what the future holds for the maritime business and how technology can be used to train, assist, and minimise accidents for future seafarers. Thank you.